Okay, today we are going to review how to multiply polynomials. So let us review what we've done in a different video. We talked about how to multiply a monomial, that is a single term, against a polynomial, more than one monomial, string together here. So what we did in that case was we just used the distributive process of multiplication over addition. What we did was we said 2x times 4x squared plus 2x times 3x plus 2x times 5. So when we distribute 2x times 4x squared, well, that's 8x to the third power. 2x times 3x is 6x squared, and 2x plus times 5 is 10x. So we know how to do that. We just multiply this monomial all the way through the remaining terms. Well, what if we now have two polynomials here where neither one's just a monomial? We have more than one term. So the good news is, as long as we know how to do a single monomial distribution, we could do these. Because what we're basically going to do is, we're going to do them one at a time. First, I'm going to pretend the 2x doesn't exist, and I'm going to multiply that 3x squared through all these remaining terms. Then I'm going to pretend this 3x squared doesn't exist, and I'm going to multiply the 2x term all the way through. I'm going to call that repeating the distribution process. So that's what we're going to do. So let's try it first. Pretend 2x doesn't exist. Here's all my terms I'm going to get. I'm just going to work with the 3x squared. 3x squared times 2x squared plus 3x squared times negative x, and don't forget the negative sign here, 3x squared times 5. And that is my first line. Well, now I'm done with this term. I'm going to start with this term. So I'm going to say 2x times 2x squared plus 2x times the negative x plus 2x times 5. And that is this second line along here. So now once I've got all that set up, it's a simplification process. I'm going to do all these multiplications. So let's see, 3x squared times 2x squared, 6x to the fourth power. 3x squared times negative x, negative 3x to the third power. 3x squared times 5, 15x squared. Going to my second line. 2x times 2x squared is 4x to the third power. 2x times negative x minus negative 2x squared, and then 2x plus 5. Now, the last thing I need to do here is I need to combine like terms. If we remember that means we look for the same variable powers here. So what I'm doing here is, do I have any more x to the fourth powers? No. So my 6x to the fourth doesn't change. Now I'm going to look for x to the third power. Well, I've got a negative 3x cubed here and a 4x cubed here. So they can be combined. They have the same variable power. So negative 3 plus 4, well, that's 1. 1x to the third power is the same as x to the third power. Then I'm going to look at my x squared powers. Well, I've got another one over here, a negative 2x squared. I'm going to add that. 15x squared minus 2x squared is 13x squared. And you might want to cross out as you go along. And then all I have left is a 10x. So 6x to the fourth plus x cubed plus 13x squared plus 10x. And this technique works no matter how many terms are in this polynomial or how many terms are in that polynomial. I can always just do them one at a time all the way through. One at a time all the way through. If there were other terms here, then I would just add those in as well. Another thing I want to look at, though, is multiplying binomials. We do that a lot in Algebra 1. So it's the same process. If I've got x plus 5 times x minus 2, two binomials, and binomials are two-termed polynomials, I'm just going to repeat the distribution process, just like we did on the other page. So I just pretend 5 doesn't exist, and I just look at x. X times x plus x times negative 2. Pretend that x doesn't exist. Look at the 5. 5 times x plus 5 times negative 2. Do my simplify step. That's x squared. That's negative 2x. That is 5x, and that is negative 10. And then I have to combine like terms as my final step. I don't have any x squared, so that can stay. But I see I can combine my middle term here. They are both have variable x. So negative 2x plus 5x is 3x. So I get x squared plus 3x, and I only have one constant term, so that stays the same, minus 10. Now this will work fine. If you don't want to learn anymore, you can stop. I do want to talk about this FOIL method, the so-called FOIL method. You see this a lot in the algebra textbooks, and teachers will talk about it, so it's worth looking at. Suppose I want to multiply these two binomials. And again, this FOIL method only works with binomials, by the way, here. I've got 2x minus 5 times x plus 3. FOIL is really the same thing we just did on the previous page, which was repeat the distribution, 2x times the x, 2x times the 3. Then I'm going to add the negative 5 times the x plus the negative 5 plus the 3. But what the inventors of FOIL have done is they've come up with an acronym, and an acronym is these letters, the FOIL, stand for other phrases. So in this case, the F stands for first. And what that means is you take the first term in each of these binomials and you multiply them. So in this case, I've got 2x and an x, so I multiply them. The O stands for outside. So I take the two outside terms. That's my 2x and my 3. They are on the outside of this multiplication. That's my outside terms. Then I look at my inside terms. That's my negative 5 and my x. And then my L stands for the last terms, the negative 5 and the 3, and I multiply them. So these are the terms I'm going to work with, and I'm going to add all these terms up. And if I do that, I have 2x squared, right? That's 2x times x. 2x times 3 is 6x, negative 5x, and then negative 15. So I can build my my product here. And then, I have to combine those like terms in this case, only the x terms. So I get that. So the FOIL method, it's really just an acronym to remind you how to do that repeated distribution. Some people call it the happy man method because it looks like a little bit of a smiley face going on here with a big chin and some hair and stuff going up there. So whatever helps you remember it. But the key is remembering you're just repeating distribution, and FOIL is just a tool to help you remember all the pieces that need to be done when you're multiplying polynomials, when there are binomials. So give it a try, give it some practice, and review this video if you need some reminding.